introduced to logarithms. And today we're looking further into logarithms and looking at some extra properties of logarithms that can help you when you're solving equations. That's what we're trying to lead up to, is solving logarithmic equations. It helps to have these properties under our belt to be able to solve those. Here's a list of some that we used last class, right, in the last video, is if anything, log base with any base of 1 is always equal to 0. Log base anything of itself is always equal to 1. Log base anything of the same thing to the power. If the base and the argument match with the power, the answer is going to be the power. And then this is the last one that we saw last time. A base of an exponent with the same base of a logarithm will knock each other out, will cancel each other out. Logarithms and exponents are inverses. That was the gist of what we were trying to get to last time. All right, here's one property of logarithms. We have several to look at today. Here's the product property of logarithms. Anytime you have a log of a product, that means two things multiplied, you can break that apart into two separate logs that are added. So for example, log base 2 of 8x, notice that here the b stays the same. The base stays the same throughout. So log base 2 of 8x becomes log base 2 of 8 plus log base 2 of x. I can break the 8x apart into just 8 and just x using addition. With logarithms, multiplication breaks into addition. So on this example, ln, remember my base has to stay the same. This is going to become ln of 5 plus ln of x plus ln of y, because all three of those things are multiplied. Any amount of multiplication can break into addition. The opposite of that, division, will break down into subtraction. Again, having the same base, log base b, log base b, log base b. So in this example, log base 3 of c over d is the same as log base 3 of c minus log base 3 of d. The division broke into subtraction. On this one, I would have log x minus log 1,000. Remember, the bases are staying the same, so this is a common log, log base 10. My answers are also going to be a common log, log base 10. The base stays the same. Another big property is the power property. If I have log of x to a power, what I can do is bring that power out to the front. So in this one, the p, notice p becomes the coefficient here. The power comes out front. So in this example, if you have a root, all right, here's a trick. Actually, let's look at the second one first. I think this is easier. This is the same as 2 log x. The power comes out front. If you have a root, it's helpful to rewrite that root as a power. So I know that things like x to the 1/3 is the same thing as the third root of x, right? I can go back and forth here. I can go any way I want. X to the 1/7 is the same thing as the 7th root of x. So this, for example, could be the same thing as ln of x to the 2/5. It already had a 2, and we're applying a 1/5 to it because of that power. So this is the same thing then as 2/5 x, 2/5 ln of x, right? The power can now come out front. All right, using those properties, what we can do is we can rewrite a logarithmic expression as several logarithmic expressions with only one argument apiece. So notice that here we started with something with more than one thing in the argument, and we ended with only one item in the argument. That's what we're hoping for when we're expanding these. We have 2 items in the argument, and we're going to expand it so that there's only one item in each argument. That's the hope. On this one, we have several things going on here, right? We have a z to the 3rd, that's a power rule. We have divided by 2 items. And so both of those items are divided. They're going to actually both be subtracted, right? Here I have division turns into subtraction. So back here, on this problem, both of those items that are divided are going to be subtracted. So let's see what happens. I'll have a log. I know my base is going to remain 2. Z to the 3rd. Minus log base 2 of x minus log base 2 of y to the fifth. Anything that was in the denominator got subtracted. That's that division rule of logarithms. I want to do the multiplication and division rule when I am writing it as an expression, when I'm expanding it, when I want to write it in expanded form. I'm going to do the division multiplication first, and then I'm going to do the power rule. So now I can use the power rule and rewrite this as 3 log 2 of z minus log 2 of x minus 5 log 2 of y. And now I know I'm done because each argument only has one item, right? I have fully expanded it. Each argument has only one item. That's what we hope for. Now, by one item, I'm talking about items multiplied. So like a x, y, I could break that apart with multiplication, right? The rules that I have are to break apart multiplication, division, and exponents. I do not have a rule that will break apart subtraction, and I do not have a rule that will break apart addition. The only rules I have can break multiplication and division. All right, this one I think it's helpful to first write it as log of this entire thing, the entire expression to the 1/3 because of this third root. That's the same thing as a 1/3 power. All right, and then what I can do is write my 1/3, take that power out, log of x plus y squared over 10. Now I can use my division property, right? I have some division going on. I'm just trying to work from the broadest to the most narrow, that furthest outside to the furthest inside. So the 1/3 was the furthest outside, the broadest stroke of this pen. The next thing is my division. So I can rewrite this as 1/3 log x plus y squared minus 1/3 log 10. The 10 was the thing being divided here. It was on bottom, so it got subtracted. Remember, division breaks into subtraction. All right, this only has one argument now. Nothing I can do with it. There is something I can still do with this. It has a power, right? So I can bring that 2 out to the front. That's going to make 2/3 log x plus y minus 1/3 log 10. We'll look again at the arguments here. 10, no way to break that apart. No way to break that. There's no division, multiplication that's going on. Here, is there any way to break it apart? Remember, my rules are for multiplication, division, and powers. And so here, since there's no multiplication, division, or powers, there's no way to break that argument apart any further. It's as simple as it can get, and that is going to be our final answer. Take a second and see what you can do with this. This is another one very similar to the last. In 5 seconds, I'm going to open it up. We want to expand it. So first, write that 1/3 as a power. Next, bring the power out front or apply it to both things. That works as well. So here, what I did first, okay, I like to say in class that there's more than one way to skin a cat, right? So here, you can bring the 1/3 out. That's perfectly fine the way that we did it here. The other way that you can do this, you can take the 1/3 and distribute it into everything. You will end up with the same answer in the end. All right, apply the quotient rule, so division becomes subtraction. Apply the exponent rule, so the 1/3 can come out. Log base 5 of 25, that's just numbers. Log base 5 of 25 is just 2. And 2 times a third is the same as 2/3. Let's make sure we didn't have another step here. Oh, we did have another step. We totally missed it. Look, this log of 10 right here, you can actually type that. That's a common log. You can type in the calculator. Log of 10, that's the same as log base 10 of 10. That's a property that we had last time. 2/3 log x plus y minus 1/3. Log of 10 is just 1. And 1/3 times 1, if we wanted to simplify that one step further, log x plus y minus 1/3. That's our final answer. I'm sorry, I left you hanging on this. We had one more step that we could do. Anytime you have just numbers in the argument, you should try and see if it comes out to a nice number, right? So on this, if we have just numbers on the calculator on the left-hand side, I have a log button and I have an ln button. If I have log 10, I can just type log 10 in my calculator and get 1. That's the same exact thing that happened here. I don't remember if we did the change of base formula last time, but I'm sure that we'll cover it today. If we don't, then I'll come back and try and cover it. We know that anyways, if we take that off to the side, right, log base 5 of 25, that's the same thing as 5 to the something equals 25. And so that must be 2, right? 5 to the 2 is 25. That's what we were doing last class. All right, reversing that process, if we want to write these as a single logarithm, what we want to do is, it says write them as a single logarithm. What we want in the end is just log base 2 of some stuff. One logarithm. Here we have 1, 2, 3. We want to write it as just 1. We can go back and use the same quotient difference product rules, quotient product and exponent rules that we've been using. So we have one thing on top. This is minus, this is minus. Both of these are going to go on bottom because they're subtracted. So this is the same thing as log base 2 of 560 over 7 times 5. They both ended up on bottom. That's the same thing as log base 2 of 560 over 35. And I can simplify 560 over 35 in my calculator. 560 over 35 is actually an even 16. Log base 2 of 16. All right, let's see if we can simplify this log base 2 of 16. That's saying 2 to the something is 16. I don't know what that something is, but in my calculator, if I do 2 to the 2, 2 to the 3, 2 to the 4, wow, 2 to the 4 is 16. Again, in a minute, I'm going to show you a change of base formula that helps you. Actually, let's go on and show it now. So in your calculator, you would love to be able to type that in your calculator, but on the left side of your calculator, all you have is a log button, right? It looks like this, log, and you have a ln button. Those are the only buttons you have. You don't have a button that says log base 2. If you ever want to take a log of something with a different base, there's the change of base formula. And what the change of base formula says is, if I have log base a of b, that's the same thing as log b over log a, or it's the same thing as ln of b over ln of a. This is written with common logs, and this is written with natural logs. Either one will get you the same answer. Notice that the higher elevation, it's not numerically, but the higher elevation on the page here, B, is higher elevation, ends up on top. Lower elevation ends up on bottom. So if I wanted to calculate this, you should take a moment and verify with me here in your calculator. If I wanted to check this in my calculator, I could type log 16 over log 2. Type that in the calculator, hit enter, and it should get you 4. Alternatively, if I didn't hit the log button, I could also use the ln button. They should both work. ln 16 over ln 2. Type that in the calculator, hit enter. That should also give you 4. Either way, it doesn't matter if you use natural logs or common logs. Either one of those is going to get you the correct answer. That's called the change of base formula. Change of base formula. And so if a problem ever asks you to rewrite as a quotient of natural logs, then you're going to do exactly this. If a problem ever asks you to write as a quotient of common logs, you're going to do exactly this. You're just going to rewrite it using either common logs or natural logs, right? Depending on what the problem asks you for, you can do that. Now, also, if you have just numbers in your problem, this didn't have variables. That was my red flag in my mind. There was no variables. There's only numbers. Then what I can do is try the change of base formula and see if it works out to a nice number. Let's try this one. I'll give you a second. So the first thing we can do is move those exponents up. The next thing we can do is use our quotient rule. Then we can apply that same power on the bottom, right? They both had the same exact power. I can put those in one parentheses to that power. And we know what a half power is, right? A half power, we've been talking about a third power, seventh root is the same as a 1/7 power. 1/3 root is the same as a 1/3 power. A third root is the same as a 1/3 power. A fifth root is the same as a 1/5 power. Here, a 1/2 is the same as a square root. Only a few more pages here. Try this one. See if you can compress it all the way down. In 5 seconds, I'm going to clear it out and show you the entire answer here. And this is what we end up with after simplifying as much as we can. Notice on the top that x squared minus 1, you could actually factor it to get from this step to this. I factored the top. The x squared minus 1 is the same thing as x minus 1 and x plus 1. And that will get rid of the x plus 1 on bottom. That's great news, right? So this x plus 1 with this x plus 1, those will divide away. All right, here's the change of base formula. It's the same exact thing that I wrote down a minute ago. Log base b of x is the same as log base a of x over log base a of b. That could be applied to a common log, a natural log. It actually could be applied to any base log, but it's useful to use a common log or a natural log because those are buttons on the calculator, right? So on your problem, in a problem on Alex, it might say write using base 10, write using common logarithms. That means we need to use one without a base. Base 10 is understood here. Common logarithms are an understood base 10. Write using base E, write using natural logarithms. ln is the button there. Remember, ln is the same thing as an understood base E. Notice again, the higher elevation on the page, the x ends up on top. Lower elevation on the page is on the bottom. This is a subscript b. Lower on the page, on bottom. Higher on the page, ends up on top in both cases. All right, use the change of base formula to approximate log base 4 of 153 using base 10, right? It tells us using base 10. Let's try it. So if we want to approximate log base 4 of 153 using base 10, that's the same thing as log. 153 is higher on the page, elevation, 153. Not higher numerically, but higher on the page over log 4. We can type that in the calculator. Log 153 divided by log 4. Type it in, verify for yourself. This is equal to 3.63 when I round, 3.63. If I want to do the same thing, use the change of base formula to write it using base E. That would be ln 153 over ln of 4, right? It says use base E. That just means I'm using common logs, ln. If I type that in the calculator, ln 153 divided by ln 4, and what do you know? It worked out to the exact same thing, 3.63. That's great news. That verifies for us that both of these formulas work. In Alex, again, if it tells you to use base 10, that means you're going to leave the base empty. Remember, this is an understood base 10. If it tells you use base E, you're going to use ln. Remember, this is understood base E. All right, let's try a few more of these. Log base 3 of 15. If I wanted to figure that out in the calculator, I want to evaluate. Then what I'm going to do, I'm just going to use ln because it's easier to write. Ln 15 over ln 3. The 3 is lower on the page. I'm not talking about value. I'm not talking about how big it is. I'm talking about it is lower on my piece of paper. ln 15 over ln 3 gives me 2.46. Try the next one. Same thing as log 3 over log 5 or ln 3 over ln 5. It doesn't matter. We get 0.682. Oh, that's the end of the slideshow. Here, if you, on this last one, if you used ln 3 over ln 5, it works just the same. All right, an important note here when you're doing the calculator, when you type log or when you type ln, it automatically opens a parentheses. You do need to close that parentheses, right? You need to close that parentheses. All right, in the next lesson, we're going to talk about solving logarithmic equations. We're going to have to use these properties to solve logarithmic equations.